One of the reasons that when we started ProdPerfect in 2018, it was January 2018, we decided to focus exclusively to start on end-to-end testing. And to that day, that's still our focus. And the reason we focus on end-to-end testing is that it's the place of most pain, right? So this is the testing pyramid. I should have included a link. I will in the follow-up. There's a Google blog post from 2015 called "Just Say No to More End-to-End Tests," right? Which at the time was pretty foundational. About the same time that Jason started Test.ai. So this thinking was really fresh in this time period. And what was common before that was this idea that more end-to-end tests is always better, right? More quality assurance is good. We want more tests. Let's just pack on as much as we can sort of get away with, and think of the constraints for how many tests to have as just raw dollars. How many people can we staff here? And that's ultimately going to be our bottleneck. This is not universal thinking. Obviously, there were some folks thinking about things differently. But that idea that we should have a smaller number of end-to-end tests as part of our deployments of web or mobile software was new at the time. And so a lot of thinking went into how do we have fewer of these? The primary reason to have fewer of them is twofold. One, they run slowly, right? So as we're trying to deploy faster, deploy more frequently, they just get in the way, right? We have a lot of people we talk to, they're like, yeah, our regression testing suite takes 40 or 180 hours. And that's ultimately going to limit either how frequently you deploy or how many builds you can test, which means you have to start making these tough trade-offs. They're the expensive part, right? So conventionally, software teams were spending somewhere between 20 and 25% of their total budget just on QA automation engineering. Which focused on end-to-end testing is a huge amount of money. And that's obviously why, you look at all the players in the space, you see us, obviously Test.ai, some newer players as well, Mabel, Testim, Functionize, folks like that. We got into the game because there's such a big opportunity here to help us do this better. And so I think everyone here is very familiar with that pain, but we see where the pain comes from in a fairly unique light. If we look at the typical cycle for maintaining QA automation, all right, we start with building requirements or understanding our requirements for the application, write out plain English test cases, develop those into end-to-end test scripts, and then maintain those. And apologies to those who see this as a little bit remedial, but I'll get through it quickly. And this process of building and then maintaining tests, it's cyclical and iterative, where as our application evolves, as we're building new requirements, we're going to build new end-to-end tests. But how does this square with having this limited number of end-to-end tests to be able to save us cost, save us deployment time? What has to happen is that the folks who are in this requirement step, and I'll just kind of rotate it again there, the folks that are in this requirement step have to use some sort of heuristic to decide what are the workflows or scenarios or stories or feature sets, however we think about it or name it. What are the workflows that I'm going to be building end-to-end test automation for? And what are the workflows that I'm not building end-to-end test automation for? And I've seen a couple of webinars where you have this kind of huge matrix of like, of kind of risk versus like feature criticality, stuff like that. But ultimately, it's a subjective process for deciding what workflows get into my end-to-end test suite and what workflows don't get into my end-to-end test suite. If you had two different smart, well-resourced QA automation engineering teams look at the same application, the same set of requirements, they will invariably come up with a different set of end-to-end tests that they believe should be the ones included in the regression testing suite, especially as we move more and more towards continuous deployment, right? And we need those testing suites to be smaller. So the problem is ultimately, we'll see these like big Excel sheets where people have, these are priority 1 tests or priority 2 tests. And then we go, well, we need to deploy even more frequently. So we're gonna have a priority 0 as well, which is great. Indexing from 0 is the cool way to do it. So we have priority 0 tests and which fall into that group. Again, it's the subjective process that's guided by some heuristics. The other problem we run into is that the nature of the tests, right, or the pathways that these tests traverse, those are ones that we as a team came up with. Who decides, what steps are these tests going to go through to test the application? It's the very people who are most familiar with the application, right? The engineers themselves. And what user experience teams understand that doesn't always get translated over to engineering is that the folks who are most familiar with the application are actually the ones that have the worst understanding of how users are going to use it, right? And this is why user experience teams do user experience research. It's why product teams care so much about product analytics, because the only way to understand how users are going to use their application, what's important to them, what workflows are they going to go through, and in what order, how are they going to, what are they going to click and then fill out a form in? The only way to know that is to get data to tell us. And so when we have teams of engineers who are very familiar with the application, filling out these Excel sheets of click this thing, fill out that form, view this page, et cetera, they're actually the worst possible positioned people to be able to match those test cases to how users are going to interact with the application. And because of that mismatch, ultimately, we're going to build a bunch of tests for an application that we run that are going to miss bugs in features that we're actually covering. Like we've covered that feature, but then a bunch of users are going to experience bugs on that feature because we use it in a different way than they would have. So ultimately what we want to do, given that we have so few tests, is focus what end-to-end tests we write on what users really care about, what's important to them. So the goal is to make sure that, the goal of end-to-end testing at the end of the day, right? We have this low-level testing to make sure our bottom level or our lower-level functionality works. But the goal of end-to-end testing at the end of the day is to be able to confidently say before we deploy, the features that our users use in the ways that they want to use them work. We haven't broken them, right? Whether that's regression or new features. And the good news is, look, for regression at least, our users are already telling us what those priorities are. They're already telling us exactly how they're using the application, what do they care about, what order are they going through things in. And so, conceptually, being able to tie these things together is quite simple. All we have to do is collect the data and analyze it in a way that tells us what our users' priorities are. Of course, product analytics can help us with this, can guide us on it. There's a lot of ways that it falls short, and when we actually talk about the juicy machine learning stuff, we'll see a few of the ways that we have to look at this data in a unique way to be able to build good end-to-end tests from it. But what we've seen over and over again, because we're analyzing these few hundred applications to understand what our users care about, what are they doing. What we see every time, right, is a head and a long tail. And these are also known as Pareto graphs. I may call them that. But ultimately, there's the stuff that users are doing very frequently, and that's a few of your features or a few different workflows. And then there's the whole rest of your application that users barely interact with. Your product team knows this. Your QA team may not be getting this kind of data. And so whether or not you work with one of these more sophisticated machine learning products like Test.ai or ProdPerfect, this kind of data, this kind of guidance for understanding what's important to your users, right, is going to allow you to go through that prioritization exercise that you have to do, right, to meet that testing pyramid structure for high-speed deployments. That data is going to allow you to understand what should be a priority and what shouldn't. These two blue lines are about two ways of thinking about how are we going to cut off where we stop building tests, right? So one of these ways is to have an integral approach, right? Where we say, okay, a certain percentage of the total area under the curve, we're going to cover that. That's actually our current SLA. What we're actually thinking about moving to, so you get a little sneak peek under the hood here, is we're saying, well, what if instead of saying we're just going to integrate this curve up to a certain point to have an SLA, right, to have a coverage level that we're happy with, what if we just instead said, what we'll do is we'll cover everything, all these workflows that happen more frequently than a certain percentage of time. And what I probably should have put on these graphs was with some labels. But the way I think about these graphs when I'm thinking about testing coverage is that these are a histogram, right? So we have a bunch of bars along here that are all each individual bar is a workflow that people go through in the application. And how tall it is what percentage of users actually do that, and then we stack rank them, right? So these are the behaviors that people do a lot, and these are the behaviors that people do frequently or infrequently. So there's a couple different ways to think about what is the top priority stuff for our user. There's some sophistication we want to add to this that I'll get to, but what it does is allows us to have this fundamentally different way of looking at coverage percentage. And this is always the sticky conversation I have to have with folks that are interested in becoming my customers, is that I'll hear people say, we have 100% test coverage. Wow, 100%, right? So how many potential workflows are on your application if you're to do a random walk, right? Just send a bot and do a random walk. 10,000, 100,000, a couple million, right? If we just think of these randomized permutations through the application. So you've got millions of tests, right? Because anything that someone could ever do is covered. Well, of course, that's not what people mean by 100% coverage. The denominator, when someone is bragging that they have 100% end-to-end test automation coverage, the denominator using is all of the tests that they came up with in a room, right? So people got in a room, you know, and I know there's rigor that's added to this, but fundamentally it boils down to people got in a room and they said, we're looking at our requirements, we've got those, what should our end-to-end tests be? We've prioritized that with whatever heuristic we have, and how many of those have we built? If we've built all the ones that we came up with in that room, great, we've got 100% test coverage. So what this means is that, again, remember that these two different QA automation teams could come up with a different set, but not only a different set of, but a different number of end-to-end tests that they would prioritize. So one team has 80% test coverage, one team has 95% test coverage. Which one of them has better quality assurance for their application? We don't know. Because we don't know because what they put in the denominator is what came out of their heads, right? One of them could have said, we need 1,000 tests. One of them may have said, you know, we're a CD team, we only need 40. And so what that means is that these coverage percentages only give us a sense of how complete we have been in our automation efforts for our own, you know, from our own standards that we've come up with. What we've come up with as a fundamentally different way to think about test coverage is user-centric, right? So it's not QA team-centric, it's user-centric, where our denominator in our coverage percentage is the total observed interactions on the application. Clicks, form submissions, page views, change events, even reloads, kind of everything we can see people do in the application, all that together, right? So we might have 10 million events, that's our denominator. And then we can say for each test or the total suite of tests, what percentage of all those interactions, weighted of course, based on, you know, how, because we want to focus on the stuff that's used most frequently, what percentage of those interactions that we've observed have we covered with our tests? And the whole point of this prioritization, if you go back to this long tail curve, is that we don't want 100% test coverage. That's crazy town, right? Because, you know, we might get 80% test coverage with the first, maybe even 10% of potential tests, depending on the landscape and footprint in the application. 100% test coverage would mean every single way that anyone has ever used the application is covered by a test, right? So we wouldn't want that. So what this percentage coverage model allows us to do is get that best bang for buck, is allow us to say, what are the few tests that we're going to write that give us coverage of what customers are, or what, yeah, your application's customers are really doing. So that's the way we think about it. And we can add sophistication to this, right? And we've already done that. A little bit is proprietary under the hood, but the big idea is that, you know, if we just take a naive approach, we take every interaction and just build some tests based on that, you know, we can, for example, swamp out less common user groups on the application that are still very important. That it might even be your money makers if they're, you know, a smaller group. For example, a lot of freemium applications, right? 99% of their usage is free, 1% is paid. What do we care about? The paid stuff. So what can we do? We can separate by user role, right? Run the same analysis on these two user roles and either balance them or get rid of a user role entirely. Say, look, we don't care about the free usage. We're only going to analyze the paid usage. Or we can actually even demote the free usage and then get a coverage level based on that role balancing, that role weighting. We might want to say, hey, look, we care about this tail, but what we want to do is instead of have no coverage for feature groups that don't have a lot of usage, we just want to have less coverage. So you want to make sure every feature group on our application has some coverage. And the more frequently it's used, the more tests we want there. Great. What we can do is, if you see these, you see these colors here, these colors tell us what interactions are close to each other, right? And so we can use node clustering to understand what's a feature group and make sure that each of those feature groups, weighted by frequency, have some coverage, so we can balance based on that. We can even have a customer come in and say, look, I have some rare features that are really important. We can add some dials. We haven't done this part yet, but we can add some dials where a customer could come in and say, okay, I see all my feature groups from this analysis. These ones are really important to me. These ones are less important to me, and overlay that on the analysis that we did with frequency. And then finally, we can look back on experience from previous customers, which is where the machine learning gets really fun, and say, what are the things that they cared about? What are the bugs that we caught? And start using some of that experience from previous applications that have looked similar in some ways, right? Login looks pretty similar everywhere. Checkout looks pretty similar everywhere. How can we use that experience to inform us about risk profile, right? Based on what everyone else has done. So how can we take the aggregated learnings of the entire world of testing, the entire world of quality assurance, to improve the quality assurance efforts for everyone? So these are all the ways that we can add sophistication to this analysis. And what I'm going to do now is talk about how we do it. So for us, what we do is we automatically build, maintain, and evolve end-to-end tests for our customers. So we own their test suite, their end-to-end regression test suite. And I'm going to keep this part short because this is not an advertisement for ProdPerfect. Anyone interested in that can follow up with us. But the way we do it is we collect that clickstream metadata where we see those interactions, analyze it to understand what workflows people are going through, what's important to them, how to use the application. We add mock data and stabilization for these tests. And then we get test code that pops out. And I'll get into a little more detail about that, the stuff that's actually interesting for this group. Maintain that code build to build, right? So as builds come through, UIs change, we need to update those tests. But the really cool part is we're maintaining these tests over time by rerunning the analysis. So the way that, in the conventional kind of old and busted method that you have to update your test suite is, as you're updating the application, that same committee of people that decided what to test in the first place has to go back and say, what tests are we going to add, what tests are we going to change based on these new requirements coming through. Part of the problem with that is you get test bloat, right? You start off, you have this team of hotshot QA engineers, start off saying, great, we're going to make sure that our test suite runs in less than 15 minutes in order to make sure that we can support and test multiple deployments per day. Or at least this part of the test suite runs in less than 15 minutes. This part of the test suite we want to run in less than 5 hours, right? So we can run it on Fridays before a big deploy, or, well, don't deploy on Fridays, but you get the idea. But you get test bloat this way because people don't know what test to demote, right? So this refresh process, all it does is add tests, add tests, add tests. And then a bug gets out in production. Guess what? You added a test because you're playing whack-a-mole. So your test suite grows and grows and grows and grows. Its runtime shoots up and its instability shoots up. And so it starts to become a problem. You guys are probably all familiar with this problem, which is why you're here. So the way that we're able to get around that problem is, look, new features are being released, how people use the application changes. So what we do is we reanalyze the application constantly. We do it every hour. So we reanalyze the application, obviously trailing weighted averages to make sure that it's not jumping around all the time. But reanalyze the application every hour, promote new events that we see to be highly important because we know they're new features, and compare that, diff that against our current test coverage, right? So what the analysis engine will do at that point is say, okay, here's what people are doing in the application. Here's what's important to them, our high priority test flows. Here's what we're testing right now, and boom. Is there a difference, right? Has a difference emerged? And if a difference has emerged, we're gonna close that gap with some new tests. And that allows us to keep this test suite maintained effectively over time without creating bloat. We can stay well prioritized, keep up with what users really care about. So from our customer's perspective, just a magic black box, plug in a data tracker to learn how customers use the application, plug us into their CI so that our tests can run there with each deploy, and they get the test results. And I can show those off a little bit later if people are interested, but the methodology is the real fun part. So what we do with the metadata that comes in is we use AutoTrack, excuse me. We use AutoTrack, developed by Heap in 2013. A lot of you are probably very familiar with it. What AutoTrack was designed for was to allow you to set up meaningful product analytics on your application without instrumentation, right? So you used to have to actually manually instrument an application for product analytics to be able to work, and product teams are like, kill me, I have no idea how to do this. Engineering teams didn't want to do it. It was a big hang up. AutoTrack allowed these analytics tool sets to look at all the metadata about an event and create like statistical similarity between different different events, so that, you know, even if something small changed, right, if something's positioned in the elemental hierarchy or CSS selector changed, it wouldn't lose the plot. It would be able to stay hooked onto that event. So we use that to be able to give us a model of the event, right? Same way that a lot of other similar tool sets, in order to increase stability, will model an event rather than just look at a single hook. We do the same thing, but we do it by just seeing it in action from production. And so with those modeled event, where, you know, there's essentially a network node graph that gets built. This is of course just a visualization of what's going on under the hood every hour, but each node is an event. Each line is a traversal between those events, right? So user did this, then they did that. Bigger nodes, bigger arrows are more common. And so this network analysis is the full understanding of usage of the application. And it's a mess, right? This is actually a very, very small application. And the reason I picked such a small one is just that it's like grokkable at all. They get much, much bigger. And so how do you possibly make sense of this? What the analysis engine is doing is it's tracing through this application, right? So we're not actually, what's interesting about this process, that what I'm describing here is there's not machine learning in action, analysis to analysis. The machine learning improves the analysis over time by getting feedback, right? And that's how all machine learning works. Like the folks that kind of hand wave, like this is AI at you, this is data science, right? These are algorithms that, that are using statistics essentially to be able to say what's going on with what I'm seeing here. And so the two cores, like algorithmic modeling tool sets that are used here for us to be able to interpret a single workflow in an application are normalization and aggregation, right? So our tracing starts at a choke point node, right? So a choke point being one where someone's at this node and there's a low probability that they go to any particular other node after that. The tracing begins first by normalizing down disparate nodes, or sorry, not disparate nodes. Nodes where the interaction is the same, but the data is different. So one of the places we'll see that is in URL slugs, right? Different users with different logins will have these UIDs in the URL slugs. In a CRM, you'll have all these different contacts. In a e-commerce application, you'll have all these different products. Right? And we don't want to build unique tests for every contact, for every user, for every product. So we normalize away that unique data that's associated with the page, with the event, you know, with clicking the product, with adding the contact. What we want to be able to do is test, how do we add a contact? How do we buy a product? So that data gets normalized away so that these events are contained. The tracing begins through that. And for that tracing to be able to make sense and not follow everyone's micro variation, right? Every user, like all the users' micro variations of usage of the application, we're essentially just canceling the noise, right? So this part's a little bit more straightforward, where we essentially answer the question, what is the core path that people are following? What's the, you know, where's the trodden path through the park where we see the dirt? And what you can see here is all these kind of like thin green lines that are bouncing around. These are variations on the core workflow. So we can even see a reload event here, right? And so we're going to cancel that noise away in order to make sure that we're following the core path that most people are doing. So what's going on in this particular workflow, by the way, so this is us kind of like looking at that matrix scroll down and seeing the lady in the red dress. Someone starts at, this is a B2B commerce application called Negotiatus. They're good friends of ours. We're going to see a little more of this stuff. someone starts at home, they log in first, and then they go to their recommended products. They go shopping along these recommended products. This is that whole kind of clustering here that gets normalized down to a generic product, categorical product. So from the recommended products, they're going shopping, they're adding it to cart. This is the checkout flow. And this is the this is some stuff that they do afterward, mostly around like if something's getting shipped or it's a subscription, how are they managing that? And we've now traced through and captured the most important workflow on the application, right? Which is logging in, shopping, and checking out. Boom, we've got a test. Or rather, we've got the test flow, right? We understand the workflow. We don't have the data for this to be able to work in the test environment yet. And we'll get to that in a second. We do that over and over again until we've reached that threshold that we talked about earlier on that long tail graph. At some point, we say we're going to stop building tests. We've built enough. We've hit our priority. And you can see we've covered part of the application, but not the whole thing. There's all sorts of fuzzy, fuzzy activity around here, fairly rare activity around here, and we want to intentionally leave that aside out of our test suite. And what emerges is, again, this is just the analysis part. This isn't the test yet, but what emerges is a Pareto graph, right? So the SLA that we use conventionally is 65% of all that observed behavior that we see. So when I hit a super majority of it, so these tests get us to 65%. Actually, these purple tests get us to 65%. This customer has tests that go well beyond that. And then this second bump are tests that were identified beyond that 65% that the analysis engine decided not to build. And this way we can, this way we now have a set of contained test cases that we're going to turn into tests. I'm going to get in a little more detail on this than I normally would with like a customer demo, because it's cool machine learning stuff, right? So what do we need to do to turn test cases into tests? From our perspective, a test case is a sequence of generic events, right? I'm going to fill something in this form. I'm going to click the sign in button. What do I put in that form, right? What login do I put in that form? What credit card do I put in that form? If I'm, adding contacts, who's my contact? If I'm adding an address, what's my address, right? Eventually, there will be like a context-aware crawler that we're building right now, that we're teaching right now, right? It's learning. That can do all of this, right? That can say, I'm looking at an application. This looks like it needs a credit card. It's probably Stripe. I'm going to try the Stripe credit card, the Stripe Sandbox credit card, or this needs an address. This looks like it's probably US based. I'm going to use, ProdPerfect's address in San Francisco, stuff like that. And where that, we can do some of that now, the basic stuff, but then all these different applications can, all of the different applications of our customers can become quite unique, right? We have some customers that are in the healthcare space or the manufacturing space, e-commerce, hospitality, e-learning, all sorts of stuff. And so the kind of data that you would want to put into these fields, so that you'd want to select, is different. So right now we have a heavy man behind the curtain approach for us to be able to get the job done every time before we've got the thousands of customers of experience needed to be able to automate it every time. And to give us the data sets we need to teach the machine, right? If you're familiar with visual AI technology, right? You need people to initially teach that. We're doing that teaching right now by serving our customers. So what happens is, for us to put in some data, let's say Geico is a customer. What we have is a data-driven workflow where what you select in this dropdown determines whether you go down event path A or event path B, right? So event path A is getting insurance for your motorcycle. Event path B is getting insurance for your vehicle, for your automobile. And these are different event paths. These are different experiences. So the analysis engine has identified that we have these different workflows, right? And it wants both of them to be tests. And it says, great, go build these tests. We're using mechanical Turk to fill in this data. What the mechanical Turk gets is the sequence of events. They know exactly, they need to go from A, B, C, D, E down the sequence of events, and they need to fill in data that finishes that. What can they do to get that? They can guess and check, right? So they get assigned event path A, and then here at this dropdown, they know I have to put in some sort of data. I'm going to put in some data. Let's say I pick snowmobile. Doesn't get me down event path A. Okay, let me try motorcycle now. Great. Now I see the events that I can select that can help me get through this workflow. Same with event path B, passenger car, they guess and check here until they see the sequence of events as the next set of available things. Obviously, we have a lot of platform tooling that we keep close to the chest to be able to help them identify this faster. It's a bit like a Henry Ford factor right now, but then they're able to say, okay, in this case, I need a VIN. They might even need to Google what a VIN is, right? What a vehicle identification number is. In time, after we've done that enough times, the engine script, the test scripting engine itself, right, which are teaching these data sets, after seeing this enough times, test scripting engines go like, I know what to put in here. This is a VIN. It's got a certain syntax it needs, right? It's numbers and letters. Needs to be a certain length. I figured it out. I'm going to do it myself now. So that's how we're teaching that. And then the same process of teaching with the man behind the curtain here is going on for assertions, right? So assertions are the third part of our test, right? We've got a sequence of events. We've got data that goes in. We've got data-driven assertions that we need. We have a rule set that goes to this mechanical Turk crew that fills in the gaps around where the engine itself is not able to add these assertions, right? Or just misses it, right? And then teaches it, right? Oh, the mechanical Turk added these assertions. How interesting. I'm now going to adjust and update my, my knowledge base and the algorithms I'm using, or the configurations of the algorithms that I'm using, in order to, in the future, make it more likely that I'm going to get, that I'm going to be asserting on this data. One of the core assumptions that we have to make this work is, look, we don't understand the underlying business logic of this functionality, right? So what do? We just assume that when we put in a certain set of data, whatever data that comes out that has, or whatever data gets displayed on the DOM to the user, right? In this case, we're in the test environment, right? Our mechanical Turks are poking around the test environment to produce this. Whatever data gets returned on the test environment, based on the data that we put in, we should assert it, right? We should assume that it's good, assume that there's not a bug, assert it. So this way we skip having to understand the underlying business logic. We say, look, I put in this shipping address, I put in this credit card, I picked this product. This is the amount of money that came out, right? This is what got returned here, this got returned here. Whatever those values are that are provoked by our activity in the test environment, we're gonna assert on, assume that they're true. Or assume that they're good in this iteration. And then since we're looking for regression, right, our tests are just going to keep looking for that in the test environment when the test suite runs against the new build. And if we see something different, right, we're going to throw an exception and have a failure. So as you guys know, in like the world of machine learning, your entire life is these long tail graphs where when a machine has seen the same kind of thing or the same thing many times before, it's really good at being able to do that. But then, as I mentioned about this kind of, myriad, this legion of customers that we have, there are, increasingly thorny edge cases the further you get out, right? So what are some of the challenges for us being able to truly automate this in the long term? Again, not only something we put on a demo, but for those of you thinking about using machine learning and AI, right? We've got one customer where I mentioned that manufacturing customer. Some of the data that they need to be able to upload and for us to be able to assert on is a CAD file, right? And not just any CAD file. It can't be a CAD file with gobbledygook. It's got to be a CAD file that like actually renders, say a pipe, right? Or a, I don't know, a plastic part. We've got another customer that they literally have to upload JSON files with molecules, right? That they're then analyzing for something. We got some customers that they have to upload government PDFs, right? They're helping governments, try to digitize that are still using paper. So they're uploading these government PDFs that they're scanning and need to have a certain kind of formatting for the analysis, their analysis engine to understand like, oh, this is a 409A form, right? Or a 83B form. It's not actually doing startup finance, but you get the idea. And so these, some of these edge cases, we're able to use our mechanical Turk crew to be able to figure out like a VIN, right? Teaching the analysis engine, when you see VIN, this is what you put in. But for them, is this really thorny stuff. How do we possibly teach a machine to automate that? And these are as yet unsolved problems for us, right? For it to be able to be truly automated. So is it the case that for us, along with a lot of other AI tool sets, is it the case that for us, there's always going to be some exception handling that you have to get some sort of man behind the curtain prepared to be able to handle, right? Will you always have exception handling for the AI tool set? Or will you just tolerate failure really far down the curve? It becomes a strategic question of how do you, what failure tolerance do you have for your product? How much COGS are you, cost of goods sold, are you willing to suffer in the meantime in order to teach this process? And these are the kinds of problems that we and everyone in the space needs to think about for us to be able to build, a machine learning driven product. So real quick, what the output looks like, because I'm sure everyone's kind of interested in like, all right, you do all this cool analysis and what do you actually produce? Our test suite runs in CI against a test environment using a script, right? So it's a node script. Here's the test environment that's running. This is a error that I found. This black line is just blocking out a lot of details in the customer CI. And so that's how our customer is running. So when we create the tests themselves, and I blocked some stuff out, I'm gonna skip this. When we create the tests, right, the tests get generated into GitHub, right? And there's just a private link GitHub for the customer. We've got a remote harness that, this is the stuff that's not machine learning. Got a remote harness that provides the resources to be able to test it against the test environment. Our customer configures, gives us access to that test environment, configures that node command to be able to run us against the test environment on deploy, right? As if they'd written the test themselves. What we're also able to do is, since we're already getting a lot of feedback from this test suite, run it runs, so that we can do that comparative analysis for us to be able to update the test suite itself. And that feedback also allows us to provide some video of what the test that ran. We could provide a web report. This is all linked in CI for the customer. Provide a web report of the test results so they can get a little bit more detail. Obviously, this dashboard allows our customers to understand what their test suite looks like in a little more detail. Remember when I said we had a pretty simple graph going on? This is a more complex one. So this is a screenshot I took yesterday putting this together. I'm going to show you a little bit of live stuff, but it's not really the point, so I'm going to keep it quick. I guess this is cool. So this is one of those. This is that same fairly simple customer negotiatus. So this is just a live visualization of the most recent analysis of their application. We can go select. These are the tests that got built for them. So we can select one of these tests. Let's say test 1, add product to cart. We can see that workflow emerge, and let me just move this. And we can see the test pathway. We can see what series of events it went through. See these brackets around here, right? These are normalizations that have occurred. Password is normalized, email is normalized, because we don't care about that data. We don't even, for those who are security conscious, we don't even collect it because it doesn't help us write the tests, right? So we just know that there is a form called email. So this sequence of events is the test case from our perspective. The data that goes into it is just, supplemental. Doesn't matter as long as it works. So this helps our customer understand their test suite a little bit better. We can go to this bar chart, right, and understand what their test suite looks like right now. And as far as test results, I mentioned this web application that allows them to see their test results. If we have a passing test, it's pretty boring. We just get a video of that test. We can do other stuff to go actually see what the code looks like, but it's written in Test Cafe. It's just JavaScript. It's not that exciting, but here we are, adding stuff to the cart. I tried to find something somewhat recent that had a bug on it that I was allowed to show. What's a bummer is this one is just a 503, right? So here's what we call it. We caught a failure to execute as a 503. Not the most exciting bug, but what happens is we can see when the test failed and the last time it passed. We can learn a little bit more about that from here. So we just get the standard output into this web application, get a screenshot. And that's the stuff, as much as that's not the fun part, that's the part that actually provides value to the customer, right? Like this web form, like everything I talked about, like goes into being able to provide this feedback on demand every time they run the test suite, whether it's in CI or whether it's from command line interface or something like that, for them to be able to get this feedback and know that they haven't broken something important to the users. And that's ultimately what we do, right? We do this without them having to do it themselves. do it better, faster, stronger than they would. And okay, I've used up 40 minutes or so. We've got a bunch of questions. Chris, this is kind of your, well, maybe it's my show. My default would be to just go through this in order of the questions that came up and tackle them as best as I can, especially if they're relevant to everyone else. Is that the best way that you'd like me to do it?
Yep, sure, go ahead.
Cool. All right, you got it. So first one is a couple questions. This one was early, so this is from Paul. One, does a human have to decide that a test is valid? So this is probably a question around quality control for us. Like, do we have quality control where a human looks at the test before it gets shipped to a customer? The answer is yes. Right now we have a delivery engineering department. There are folks who are actually like way smarter than I am. Most of them work out of Boston. And they're our kind of customer success team on crack. They all have engineering degrees. And part of what they do is make sure that when tests are going to customers, that like the tests make sense. It is of course always possible with machine learning for like gobbledygook to get spat out. So they do a QC process on that. If it's junk, they'll send it back with some notes for the machine to get updated. There's a data science operations lead who makes sure that if the analysis engine is having any trouble, that it gets maintenance. And that validity test has a few rules, but some of it's, and frankly, some of it is human, can be human instinct, though we mostly don't rely on that. The place that people are often most interested is like, what if there's a bug live on production that users are experiencing and they're like going around or they're just getting stuck? What happens? What's fun about that is that often when we're bringing on board a customer for the first time, this isn't our intent, but we'll actually find a bunch of bugs on production because the analysis engine wanted to build a bunch of tests that had bugs in them. So that human check is what allows us to catch that. And then saw something talking about testing a single widget. Doesn't sound very end-to-end. Maybe I need to update the FAQ. Paul, if you're still, after seeing the presentation, because I know you sent this at 5:01, if you're still interested in that question, elaborate further down and I'll get back to it. Because I'm not even sure what you're referring to. Let's see. Also, Paul, oh my gosh, Paul asked so many questions. This is great. So also, Paul, using live data sounds great, but on many sites that user path will only work if you start with an account which is in the same state as that user's account. How do you deal with that? Great question. So one of the things, or an example that I like is, look, you've got, you have to have, you have saved states, right? Where you have like certain data or even just object states for a user. And how do you, if you detect a workflow that needs a certain state or a certain set of data to be true, how do you possibly turn that into a test? And the short version there is in the test environment. So let's assume that we've actually even got, like, the most complex version I can think of is we've got a customer called bridge.legal, and they're an immigration paperwork as a service. And the way that we what's going on with them is, like, they have this form, right? This like web form with states that are being updated by all sorts of different users, right? So the immigrant worker, the company trying to hire them, the lawyers, and the government are all updating this thing. And it actually goes on for a very long period of time. Like this can take months. So we're actually getting is a whole bunch of different user groups that are in a whole bunch of different states along this process. And like during the sample set that we have, none of them have even gone start to finish. So we have just like these snapshots from across the thing. It's chaos. And what ends up popping out in the analysis engine is a bunch of snippets. And we don't know the order, right? Which is bananas, because how could we? Because we don't know the state. We only know the interactions on the application. So this is a very astute question from Paul. So here's how we do it. We actually assign these tests to be populated with test data, these test flows to be populated with test data in a random order. And one of the exception handling, which happens constantly, but one of the exception handling steps for the engine or the mechanical Turk is essentially there's a button in our platform where they can go, I have no way to be able to add data to this test, or I can't even access this page. Please kick it to the bottom of the queue. And by being able to do that, what happens is they'll just keep going through tests until they get to the one that is at the beginning of that workflow, of that extended workflow, that sets up the data or sets up the states for the other tests to be able to work. And they might be completely linear, at which point they're going to be doing this like queue kicking rotation for ages from their perspective. You know, for us, something that's that gnarly will add like a day or two to our, you know, that gnarly, it adds like a day or two to our process to be able to sort through that order, but allows us to sort through that order without our team having to like sit there and scratch their heads and sort it out. And so I don't know if that's Paul, I don't know if that's a satisfying answer, but that's the high level. Great. So can you direct the AI to look for crashes, errors, user abandonment? And if you can, assume you need to talk to dev and then make a test after a fix or et cetera. So the short version, excuse me, the short version on that is we just have not directed our analysis engine towards production monitoring yet. We may someday, but like, to be honest, there's some really smart folks over at like, I don't know, just picking off the top of my head, like App Dynamics and Datadog and oh gosh, I'm gonna anger somebody that I left them out, but and I apologize, but we're not doing that in part. And I guess user abandonment or cart abandonment is also a whole bunch of like product analytics tool sets that are really good. And the short version is we're not going after that because there are people who are just so much better in this space, in that space than we are. They're focused on that niche. They've got a lot of experience. They got tons of resources, and we'll probably never become truly competitive there. And so we're sticking to pre-deploy testing. Some very nice words from Jason and Chris, which people can read if they want to. Thank you guys. That was I'm now blushing a little bit. Paul again. So do you and can you use different or similar data every time you run a test in order to increase the odds of a failure? Or maybe that's a different application, smiley face. Great question. So excuse me. So for example, can you know, we're going through a workflow, let's say that shopping workflow, can we rerun it multiple times with different products or with different credit cards or with different, you know, or for example, just, I know a lot of people like to stress test login with many different permutations of email addresses and login syntaxes, or sorry, password syntaxes, some of which are even designed to not pass. Not in the sense that the test is designed to fail, but that the test is set up to say this syntax of password should not work when you're trying to sign up, or this password is the wrong password. So it should, the thing you should be seeing is sorry, you couldn't log in, and do that multiple times. From our perspective, so can we do that? Yes, we can. It would require, right now, we don't have the customer dashboard with all those knobs they can tweak to be able to do that. So for the moment, we actually don't. And one of the reasons we don't is that we're like such zealots about the testing pyramid, right? Of minimizing the number of end-to-end tests, that when customers ask for that, we, you know, maybe I'm biased because my product doesn't do it yet, but we ask our customers, hey, can you push that to a low level test? So for example, like running data through, you know, if you're trying to like spec test or like data stress test, a certain function, can you do that at a lower level test where you black box it, send in 1,000 permutations of that data, right, and really stress test it with a much more stable, much cheaper, faster running test, rather than have all the load of an end-to-end test to test those data permutations. So that's our philosophy on it, is that we'd actually encourage people not to do that end-to-end. And that philosophy, just my disclaimer, is that philosophy happens to tie very well into what our product does. And I know smart people that disagree with me on it. So great. Eric asks, do the Mechanical Turk workers work inside of the web app under tests as part of the human intelligence task? Yes. So the Mechanical Turks get login access, client login access to a test environment. So not access to, you know, they don't need, what the beauty of this is they don't need access to code or anything like that. They're just able to play around with the test environment as users, right? Which means that, so what's the risk is like they could populate they could populate a ton of data, a ton of junk data into staging. So as part of our, as part of setting up a customer, we make sure that we have a database reset or clear API, right? Such that if we start to overpopulate the database, right, something goes berserk, we can clear it and reset it so that we don't choke their staging environment with too much data. Because typically staging. Typically the test environments are somewhat underpowered, right? Certainly compared to prod, and so it also means that we can throttle the number of mechanical Turk human intelligence tasks going on the test environment at a given time. The load is highest when we're first onboarding a customer and building a test suite from the ground up. And so there's a little bit of like our customer success team or our delivery engineering team wears very white gloves for this process, because there are some performance risks for that test environment while we're building that we need to manage them through. As far as security risks, maybe you're not even asking about security risks. Nobody's worried so far, just because if they're giving us access to it, then they've essentially kind of like conceded that people can mess around with our test environment. So the test environment does have to be free of any like actual data that people care about being exposed, right? So for example, like if customers are copying prod data down to the test environment, we can't work with them, because we're not set up to be able to protect data being displayed on that test environment were to include something sensitive. Paul's got some more great questions. Oh, and Paul said later, yep, that's good, thank you. So number 6, if you do more aggregation, doesn't that reduce the number of tests and thus increase the coverage number? If so, how do you decide how much aggregation? Great question. So God, Paul, we should talk more later. I'm really delighted. I'm really delighted with how sharp you're seeing into this. So, so yes, we thought about that problem, and what we actually ended up doing is making sure that the coverage, so that the denominator of the coverage calculation. This is actually worth bringing that back up, because it's super important for us to be able to hold ourselves accountable to our customer for what we're covering and what we're not, right? It's the way that we get trust, right? Because like what we're doing is so crazy radical. Nobody's, someone is saying like, you're just letting a machine decide what to test and I have to let go. Like it's actually hard, right? So how do we have this accountability with our customer? What Paul is asking is like, when we aggregate, what we're doing is canceling the noise of these variations on these interactions, where what's going on, and I'll get into actually a little color on this. Like, here's an example where someone was at my recommended products and they clicked the privacy page, where it just includes information about privacy, and then they went somewhere else, and then they end up coming back on the path, which is why the green thing is here. And look at all of these other ways that people have done that. When we're building a test, we're canceling out that noise. So we don't want the test to include that because it's junk, right? When we are calculating our coverage, the denominator in that calculation does not ignore those variations. So at no point is the denominator in the coverage calculation being reduced. It is always the total observed set of user interactions. To Paul's point, the aggressiveness of our aggregation is something that we can tweak. It actually leads to some different challenges. But to answer your first question, and then I'll get into another interesting challenge, because I think you guys are interested in some of these challenges in building a product like this. So what happens is if we aggregate down further and a test includes fewer interactions, the coverage number for that test will drop because the denominator always includes all the interactions. So if a test is now smaller, its incremental coverage number is lower, because out of 1 million interactions total, that's it, that's never changing. The test now covers, 20,000 rather than 25,000 of those. Again, because this is weighted by frequency of use. So great question by Paul. What are some of the challenges of getting this aggregation number right, and why do we need machine learning on the analysis engine itself as well as the test creation process? Well, it's that if you go back here, looking at looking at this this workflow, it seemed, you know, if this graph is like visually representative of the actual like mathematical situation here, it looks pretty intuitive that these variations on the workflow are noise, right? There are people kind of wandering around. Like, that makes sense, right? What if some of these green lines were actually a little bit thicker, right? Or like closer to the thickness of this green line? Is it noise, or is it of a workflow variant that's a real intentional variant, right? So for example, if you go back here to our Geico example, right, at motorcycle and car insurance, folks split up, but then they come back together, right? The end part, right, in terms of interactions on an insurance page, the middle is different because it's like, oh, tell me like slightly different details about like your boat trailer versus your horse trailer. But then it comes back together. So I'm actually gonna break a cardinal rule here and draw some stuff live for you guys. But you know, it might look like this, where instead of a straight shot, you have A and B, where A is here and B is here. The beginning and the end of A and B are the same, and the middle is different. This is pretty common. So how do we statistically know at what point a variation is noise versus a real variation that we should be testing for? It's a gnarly problem that I know this is where humans are providing feedback to that analysis engine. So our data science ops team will actually provide QC on the initial analysis engine output, because those knobs need to get tweaked. And also it's teaching the machine. So we still have a human touch on that. And it adds, you know, tons of very high cost labor to our process, right? Which you know, in time we'll get rid of, right? As we teach the engine. It's one of the fascinating things. I'm sure like you know, there's some founders in the room that like have to be held accountable to their unit economics, right? How do we even track what's actual COGS and unit economics versus what's product design, and how can we predict what our future unit economics will be at what point when we've taught more of this to be automated? Fascinating problem, but those are the kind of challenges we run into from having options and how aggressively we aggregate. Really, really great question. Let me get back to it. Okay, Eric asks, if we're deploying a new feature, how much time would go by before the analysis process was complete and the test automation is written for the new feature? Common question. Our analysis engine is running that diff every hour. So within an hour of the new feature being released, we're now aware of it. And what one of the things that we programmed, it's kind of a hard code program into the analysis engine, is that when we see brand new events that we've never seen before, after we've established a critical mass of data or a baseline, the gain on those. So in deciding what to test, there's all sorts of these tricks that we talked about earlier, like user role balancing and stuff like that. That's not just a naive kind of look at the graph, look at the Pareto graph. This is one of those tricks where the gain or the weighting on those events is cranked up to the max, such that a small amount of usage will promote it to being turned into a test, at least temporarily. And because we'd rather err on the side of having those new feature sets, if they're being used with any regularity, with any repetition, be promoted into tests. The total turnaround time is going to vary on one thing, and that's our ability for it to be written stably. So we're not going to ship any tests that aren't stable. And every now and then, you know, there's something in the test environment that stops us from being able to make this test stable. It can be as short as within the day. That kind of Henry Ford factor we have allows us to shoot it right through. I have, due to test environment instability issues, I've seen it take weeks, which is always shitty, frankly. And requires a conversation with our customer about, like, look, we've got this, like, this test is generated, it's ready to go. It's just not stable. We need to work on why. But it's usually, it can be within a day. Jason asks, do you see folks putting their test environment live on the net, or are you often using reverse HTTP proxies, other access for those staging environments? Yeah, we are usually seeing a proxy or a VPN to get that. We'll often IP whitelist, and the way that we've got our own tunnel for our human intelligence task folks to be able to get access to that in a controlled way. So it actually allows us to get some good access control in there as well, which is neat. Paul says, aggregating does not diminish the denominator. Good to know. So you can't cheat as I was imagining. Thanks so much for all the answers to my many questions. And everyone agrees that there were some great questions. So we are now out of questions for the moment. Chris, if people want to ask questions out loud, I'm going to let you moderate how you want to do that.
Sure.
Because I know it can get chaotic.
Yep, I understand. I'll first, let the co-organizers or the leaders in the group ask some questions. Jason, do you have anything you want to ask?
This is, I'm going to share a secret. I'm like, Jason, I didn't know you're going to be here. And I'm like, I'm excited and also excited for and also intimidated by any questions you might ask. Because if any hard balls are coming, they're coming from you. Oh, Jason, we might have lost your sound. I don't know why. I heard you chuckle, and then, Chris, are you able to hear him?
Nope.
Okay.
Are we good now? Do you hear me?
There we go.
Yep.
All right. You shouldn't have even heard a little bit. That's weird. No. So I think the most interesting, I think the core technical issue here, you already elaborated on it, was the how do you normalize these states, right? Like how do you identify whether that's a specific shopping page is relevant, like the product page, or if it's just product pages in general, right. And how many of those paths you collapse, right? So I think that's the fact that you said it's a very gnarly problem made me feel better, because I start to get an argument and I start to have I think I have an idea of how to do it, and then I'm like, no, that doesn't work. Like every time I have an idea, it's worse than the idea I had the time before. In terms of figuring that, it just still comes back to a human deciding whether those are significant or not. It's so I was actually felt good that you also struggled with that.
Yeah. And I think this is a great kind of very rare opportunity for us. We like to be transparent in our sales process, but this is a great opportunity for us to like be vulnerable together about like the limitations of machine learning. And I think like a lot of people in this group will know this intimately. Mm-hmm. But I think a lot of buyers don't, right? They hear like AI is such a great like flim flam kind of smoke and mirrors term that gets people to stop asking questions. And I think this is a little bit of a buyer beware moment for everyone that's thinking about, that's buying products in the ML space, that you do need to ask your salesperson about some of these limitations. So, as Jason and I just shared, the only way for us to be certain, and certain's even as soon as you start talking to data scientists about the word certain, like so you just don't use that word with them, right? Because like even machine learning is all based on probabilities. But like the only way for us to be confident, like ProdPerfect to be confident that the tests that we outputted are the right ones for the customers, is for a human to look at them, right? We've never shipped a test suite without a human looking at it first. And you're right, we do not, like, it's not obvious to me how we get to the point that is done, right? That day is over. And, and so I think like, I think for those of you who are kind of shopping for ML AI products, sorry, Jason, I you wanted to say something, and then I got on my soapbox, so I'll shut up in a sec. But those of you who are shopping for, I think like asking about, hopefully one of the things this webinar does or this meetup does, is like help educate you on the generic limitation or the general limitations, so you know what questions to ask and push people on about how they ensure quality and how the data science is actually impacting output.
Interesting that you brought this up, Jason, right? And in fact, this is sort of known as the test oracle problem in testing. And for those of you who want to know what, this is a shameless plug of mine. If those of you want to know what the test oracle problem, please join us next Thursday for my talk on the survey paper on AI testing and so on. Anything else to add, Jason?
Yeah.
You can see the other thing I like that you bring in kind of business aspect of it, of where like a lot of times testers think there's a capital T truth, right, in terms of what's a test case or what's even a bug versus a feature. And we also struggle with our customers is sometimes, you know, if you have a different person in the role, truth changes. So like if you just swap a test lead out at a company, their definition of what is a duplicate test versus unique test will be different. So there's actually no formal oracle, and you always have to interact with today with the testers. So because they're the ultimate judge of quality and value, right, from a business perspective. So yeah, it's interesting because you see, it's good. That makes me also feel good that you're also iterating with your customers and see this ambiguity and trying to resolve it. But you always, in the day, it comes back to a human deciding whether it is valuable or not, and deciding whether the AI produced something of value or not. But like you say, it's good to give them those dials and have those dials in the infrastructure where you can tune it to different customers, right? Tune it to different situations. So it's good to see a similar evolution in the kind of the tooling to interact, to deal with different customer, you know, biases in terms of what is their oracle. So it's cool. It's awesome. This is fun. Thanks, man. Thanks for sharing.
My pleasure.
The other, sort of co-organizer for this meetup group is Ron. Ron, are you still there? Do you have anything you want to say or have a question?
Still here. I enjoyed the presentation immensely. Thank you so much for presenting.
My pleasure.
I really hope we can connect in the future, and I look forward to seeing more progress from you. Everything makes all the sense in the world.
Cool. I'll make sure to reach out. Actually, to both of you, because Jason, there's some. We'll talk. This was a lot of fun. You know, most of my conversations around this. So this is just me saying thank you to all three of you. You know, most of the conversations I have around this are sales conversations, which again, we try to be transparent. We are transparent. There's no trying. It's a very do or do not thing. We're transparent, but like we don't have the luxury of being able to say like, oh, this is like an interesting sticky problem that we're stuck on, and like you'll be really interested in this interesting sticky problem. That's not what, like when someone's like trying to buy the right testing tool. Yeah, again, they want to know the limitations, but we don't get to like share with fellow experts and fellow enthusiasts the heart of the work. And so yeah, this I've particularly enjoyed this, and particularly enjoyed the quality and intelligence of all the questions. So to the audience and everyone who got involved, really thank you.
Okay. Anybody else have any questions that you're dying to ask? Going once. Eric, do you have anything? Eric Hermansen, do you have any questions?
Yeah. Can people hear me? I'm new to Zoom.
I can hear you well enough.
Okay. Suppose you have some test cases that they're just sort, you know, you've got to have them covered. Okay. Is there a way in your process to have, like, in the same test runner, some of these test cases, like we kind of don't care, like if the analysis says it's not a popular path, we still want it in there. Is there a way to kind of get those cases in there too?
Yeah, yep. the CEO or executive user flows, right?
Exactly.
Yeah.
And it's also, I mean, it's the CEO user flows, and it's also the ones where, again, like you know, for a little sympathy for the CEO devil there, you know, where the heck did I put it? Yes, somewhere I even added like these, you know, opportunities for high levels of sophistication to make it smarter. Like, am I sharing? Oh, here we go. You know, to make the analysis smarter and not naive. Like, these are new, and this list is going to grow, right? There's all these other ways that we want to do it. So like, we know that. I think one of the things that, you know, kind of Jason and Chris alluded to that's really important is like, because there's no perfect answer, we can't say that, you know, we can't say that what the customer wants is wrong. Not even just from the like American, the customer's right perspective, because I'm going to tell the customer when I think they're wrong. But But I think some of these are important. And right now, I think like when someone knows something is a high priority because like a true high priority because of their experience, it's a real thing that we should pay attention to and that we should be learning from. But all that said, the short version is the way we do it right now is super clunky. It's ask us and we'll make it. What's coming out next is a test recorder, kind of studio environment that a customer can use to direct us, right? So it's a Chrome extension that when they say like, hey, I want to add these tests in the environment, they can send someone to click through, right? And create it. And it's actually, it makes things easy for us. And now why not do that all the time? Well, then we'd be Mabel and, it'd just be a different philosophy. And I'm super impressed by Mabel and obviously, so, and so it's just like, it's for a different kind of user with a different kind of philosophical approach. But so we're going to be, we're going to have a like less awesome test recorder tool set for people to be able to add these supplemental tests to our test suite and we get fully integrated and run together. Or run separately. And this is where like, there's all these other options of things that we can do around this. Like, oh, maybe, like you saw from Negotiatus there, they have like 25 tests, which for them is, and a lot of them are long and beefy, and a lot of them this is great for them. They deploy like 12 times a day, and that's what they want. And someone may want 1,000 tests, and like, do we break up the test suite into like, or give them the ability to say like, actually, I want the head and the midtail, and how do I then also, if I have a bunch of, when I have a bunch of tests, how do I then understand the ProdPerfect test suite well enough to be able to compare that to the high priority tests I have and say, where do they overlap and where do they not? That's another kettle of fish that we've actually not figured out. So right now we literally just ask people to talk to us about it.
Actually, one quick, it's really nerdy, but I mean, a little nit, but like, I was also thinking that it'd also be cool just to have some random rotating samples through the tail, just so people think that, so you don't have to pay the price of running them all, but you can still sample from that and still get a good approximation of those corner cases without having to run them all, right? But I don't know. But I love this. I love this idea of prioritizing based on usage. It's also an obvious metric that customers get, right? Like if people are using that path a lot, it needs to be tested more heavily. So you quantify it. And I want to add to the best slide is the one where you have the the old way, right? Like the Matrix one, but it's it's crazy.
Oh, it's Men in Black.
Yeah, well, it's Men in Black. That's right. Yeah. I'm not a good movie. I have zero memory for movies for some reason. That's right, because it's Will Smith on the right.
Yeah.
But the crazy thing about it is this is like the most important slide in my opinion, because like today we just have a human sit down, depending on how much caffeine they'd had that morning and how much time they bother to spend on a whiteboard with other people, and they just write tests down, and then somehow that's the oracle and that's the right way to do it is so archaic, right? It's like a blacksmith in a medieval village. But
it's
I love
voodoo.
You're taking it where you use the machine to generate the data so that they can make more intelligent decisions, right? Like there's no perfect decision. There's no formal full oracle answer, but at least you're showing them the breadth of the things that they need to be thinking about. So it starts the conversation and thought process off from a more formal perspective. And I think that's super awesome. And I haven't really seen anybody do that. I'm impressed. Nice. And I'm super happy to see it.
I will confess. So for those who want to meet the geniuses behind this, I'm just the guy who's good at talking. Dan Whiting, my CEO, and Wilson Preston Funkhauser III, our head of data science. They're the progenitors of this, and my job was to help productize it. But it was obviously very innovative approach. That's been bloody hard to implement, let me tell you. And that's why we're like, if it was easy, everyone would do it, right? Or anyone could do it. So thank you. We've actually got one more question from Paul, a suggestion from Paul. And then I'll turn it back to the bigwigs here. He just said, for those recording a test, might keep in mind that they might want specific values in that test rather than whatever we come up with. One of the cool things about the test recorder, if we give it to the customer, for them to be able to get through the test environment, they have to be able to add that data. And therefore, actually the easiest, the cool thing is like the laziest thing we can do is just take whatever data that they give us. And so they end up getting what they want to. So anyway, sorry, back to you guys.
Okay, does anyone else have a question for Erik? Going once, going twice. Okay, thanks everyone. This was an awesome meetup. I think everybody was very, and Erik, I mean, hats off to you guys. To a large extent, you know, prioritizing tests to a large, you know, has been like voodoo, and that's why, you know, people hire test managers to figure this out. And even then, it's never foolproof, right? And there's no science to back up. You know, it's like, you know, why. Problem is NP hard, you know. You don't have that kind of benchmark to say this is what the science tells us. Right. And so this actually is a very good idea. Okay, so thanks everyone.
A great setup for next week's talk, because I think.
Oh yeah.
Well, what's particularly cool about it is and the reason I think everyone here should go is that, in particular, you know, you heard us talk about this, the test oracle thing. We have a way of looking at it, you know, obviously with this user-centric approach, which feels pretty good. But what Chris will be talking about next week is all of these models are trying to approximate truth, right? Try to approximate reality, the best reality that we can. And the cool part about the test oracle problem is we're not even sure what that is. And so it kind of elaborates why these problems are so interesting. And yeah, so I'll be going. You guys should too.
Okay, cool. Thanks everyone. This was great.
Have a great night, y'all.
Yep. See you the next meetup. Thanks. Bye.